In the following video, we need to find the second derivative of a function. The first thing we're going to do is to rewrite our function in a form that makes it easy to differentiate using the chain rule. So I have removed this bracket that is raised to the power of 3 out from the denominator, and I've rewritten the exponent of positive 3 now as a negative 3. Our first step towards finding the second derivative is to find the first derivative. So that means we will differentiate y with respect to x, and we'll get the answer of negative 15, then in brackets, 2x minus 3 to the power of negative 4. That is now the outside function differentiated. Now we have to multiply this by the differential of the inside function, which is just 2. So our first derivative is negative 30 2x minus 3. In previous examples, I've always said it is better to leave your expression with positive exponents. Because we now have to find the second derivative, I am not going to rewrite this with a positive exponent yet, because leaving it in the current form is going to make it easier to differentiate this first derivative. So your second derivative is found by differentiating the first derivative. Now, how we write the notation for the second derivative is as such. Yep. And we differentiate our first derivative by the chain rule, following the same rules as we have learned so far. So the negative 4 would times the negative 30 and become 120. Then we'd have 2x minus 3, all in brackets, now to the power of negative 5. Then we'd also have to times that by the differential of the inside function, which is 2. So we are left with an expression of our second derivative of 240 2x minus 3 to the power of minus 5, which, yes, I would recommend now we rewrite in the form of 240 over 2x minus 3 to the power of a positive 5. And there we have it. We have found the second derivative of our function y equals 5, bracket 2x minus 3 to the power of negative 3.